Oh, now it finally doesn't default to the stupid share my audio, dude. I would not take that, bro. You about to stream?
Hello.
Yo, what's going on, dude?
Hey, Dr. Go, how's it going?
Good, good. Sorry, Windows needed to update, so I'm sorry I'm 5 minutes late. All good. Man, kids being weird first. What's going on? Yeah, there's a lot going on in the chat. Sorry, let me see this. Probably gonna go to biomed because aerospace is hell. Yeah. Okay. Y'all yapping here, looking like that. Doctor, can we go over some eigenstates, eigenvalues, like how to find them? I have to go to my research thing in certain sense. Cool. Yes. Internal. Let's bring internal up. What's up, internal? What's going on? Skibbity.
That's dope.
What's up, brother?
What's up?
How's life, dude? Is it Friday yet? No, it's Wednesday, right? I wish it was Friday, dude. It feels like Friday. I'm like, let's say not for Friday. No, dude. I'm sorry, dude. No.
I want to ask you something.
Okay, what do you want to ask me, dog? I got a lot.
You know how you're gonna play Roblox? You know how you're gonna play
Yo,
Roblox
there's
for
an
the
echo.
weekly?
Yeah, 1 sec. Let me fix that. Sorry. Let me stop streaming. Let me share my screen again. Sorry. I don't know why the fuck it does this, dude. Discord, fix your shit.
I don't know if it's actually me that's causing it though.
Oh,
Is
yeah,
it?
it's better.
Is it better now?
Yeah.
Is it echoing?
Yeah.
Wait, is it
Yo,
echoing?
Ethan,
Is it not
talk.
echoing? Ethan, talk. Is it
Because
Ethan?
every time everyone talked, it was echoing, but I'm not hearing echo from my side either.
Okay, Ethan, talk.
Can you talk real quick?
Talk, Ethan, do. Bruh.
All right, so you remember how
Yeah, it's way
you're gonna
better.
play Roblox
Okay, good.
weekly game this
Yeah,
week?
Saturdays meet Roblox. Yeah.
Okay, but which game are you playing actually? Like, there's millions of experiences. What are you gonna play?
I don't know. Probably that
Are you
Epic
gonna,
mini
like-
games. I like Epic mini games. Probably Epic. I mean, y'all can fucking choose if you want, but yeah, I like it.
Competing in a simulator.
What is it? What simulator, dude? God.
Compete against each other in simulator. Whoever wins. Like whoever.
Oh my
and then
God.
do like a battle in the end.
We could do Blocks Fruit, or what's the other one that you guys play? Was it the was it the bouncy ball game or something? Fuck, I don't know. There's a bunch of them.
I think I know the one that you gotta slice the ball.
Yes, yeah, you gotta you gotta rebound the ball to each other. One. Murder
Yeah.
Mystery 2, that's a fun one. Yeah, I played that. I played the one with you, Ethan. Right? We did that where we were all in the preschool or something, and then the monster came out.
Yeah, bro. It's time,
Blade
it's
Ball,
time
that's
for
the other
one. For you to shave.
Yeah, Blade
You
Ball,
got so
yeah,
much
but which-
time.
I ain't never shaving,
What are you
dude.
talking about?
No, ain't never shaving.
Dr. Go, what are you talking about? A preschool and start attacking us?
I've been letting my beard grow too.
Show it, Ramiro. Show your beard, dude. I'm talking about the
You see?
Yeah, 1 second. Let me see. Let me get you, dude. Damn. Okay, buddy. I see you. Yeah, you got that Mexicano beard, dude. Yeah, dude. I'm about to start calling
yeah.
you like Papi Chulo.
No mames.
That's-
No mames, way.
yeah,
No mames, way.
so yeah,
That's too funny.
yeah, you,
What's up, Ethan? What's
yeah,
up?
so you were talking about a preschool with a monster or something?
Yeah, there was a preschool and a monster or something. I remember something like that.
Are you
happens.
talking about daycare then? That's the
Yes,
closest they can come to.
daycare something. Yeah, day scare daycare
Yeah,
or
just-
something.
It's just daycare. It's just daycare.
Okay, cool. That's a cool game. Yeah, we could play that game maybe.
Also, I need to show you something that might be a little cooler than this. Than
Okay,
the bear.
show it to me. Show it to me real quick.
Twitch chat.
Twitch chat. You're putting it in the Twitch chat? What are you doing? Wow, 45
I forgot to
stream
grab my
streak,
camera.
dude? What, you've watched 45 of my streams in a row? Jesus, that's dope.
Yes.
That's dope.
That's so dope, dude. That's so dope. No, that wasn't
I
Ethan. The
would
monkey's
do
like, that's
that.
not Ethan, dude.
I would do that, but my life is too busy.
It's okay. I always say come in, come out as you need to, right? I had some really nice words from Demented today. Let me see. Let me see if my Discord will finally show the right screen. Can you show the right screen? There we go. Awesome. Yes, here it was. What was it? This was happening earlier today. Yes. Demented said, "Hey, Dr. Gold, I owe you like so much. I got into every university and college I applied to because of you. Congrats." Yeah, dude. For sure, dude. I mean, that's the whole goal of what I do here is to, like, help you guys get into college. College is great, dude.
That's
Medical,
dope.
It's a fucking party,
engineering,
dude. Yeah.
Software, aerospace, engineering, mechanical, and computer. Nice.
Yeah, look at that, dude. Yeah, biomedical engineering, software, aerospace engineering, mechanical, and computer. Dude, that's like all the top tier fucking majors. Good job, Demented, dude. Says probably going to biomed because aerospace is hell. Yeah, I will agree. Aerospace engineering is tough. It's one of the tougher majors to do. One of my friends had to drop out of it, and then he ended up selling pizza for a while for Domino's. But then he became a pilot, so everything ends well at the end. Now he makes way more money than me.
If you want to become a pilot, just go to the Air Force.
Yes, you could do the Air Force. Yeah, a lot of retired Air Force people become pilots. Yeah, that's for sure. I know that for sure. That's a
Yeah,
thing.
because in the Air Force, be truthful, they teach you on hand. They don't just teach you in classes, sit and then wait for on hand. They teach you on hand experiences,
Mm-hmm.
so you can
No, I
learn
agree.
quicker. Because they need people in the air as soon as possible.
Yeah, they do.
Yeah,
They
so
do.
see,
There's
the
a big
thing
need
with the
for
Air
it.
Force, yeah, the thing with the Air Force, I remember correctly, you need a certain requirement of vision. I think you need perfect vision. I'm not sure.
Oh, well, yeah,
and
to fly fighter
the
jets,
fitness
yes,
requirement,
or you can get PRK. You can get PRK surgery, I think.
yeah. Oh, and the fitness requirements aren't that strict,
Uh-huh.
but they're not the like they're
Yeah.
it's not like it's
Well, if you
lenient.
fly like helicopters and stuff, I think you're allowed to have glasses. It's just the reason why they have the requirements with fighter jets is because if your glasses were to come off and you couldn't fly, like you're screwed. And also those jets go so fast that you have to have really like perfect vision to be able to spot out like
Yep.
enemy planes like in the middle of nowhere. And then the reason why they don't let you get LASIK is because when they do LASIK, they make a slit in your cornea. Do you guys know about this? Do you know what LASIK is? I don't know if you guys know what LASIK is. I got LASIK done actually.
It's a surgery for your eyes, isn't it?
Yeah, this is well. Let's not show the gruesome thing, but yeah, this is what they do. They one sec. Yeah, they basically they cut a flap in your eyeball. They hit it with a bunch of lasers, and then they put it back on, and then now you don't need glasses anymore. It's like permanent contacts. It's super cool. I got it done actually. That's why like these glasses are fake. Like I used to always wear glasses my entire life, but then I got LASIK
I want to
done.
get it done.
Yeah, the only issue is that
This
this flap at high G's, so when you're in a fighter jet doing really fast shit and whatnot, it splits open. Yeah, it's not good.
down.
So they make you get PRK, which PRK doesn't do a slit. The only problem with PRK is you can't see for like 2 weeks. LASIK you can see like the next day, which is really cool because I needed that because I teach so much and I was like I can't be out for 2 weeks, so I got LASIK done. But I'm not
I
gonna
would
be a fighter
rather
jet anyways.
I would rather be out for 2 weeks.
At your age, yes. At my age, I wouldn't be able to pay rent. I can't take 2 weeks
Well, either
off.
way, I pay. Yeah, that's true. Never mind. I'm chilling because either way I pay rent.
All right, cool. Let me start off the stream because I got to get through a lot of questions, and I'm a little bit limited for time today. So let's start it off. All right. Welcome, everyone, to the Actual Education Office Hours live stream. Stream helps you out with math homework, science homework, life homework, all that stuff. Sweet.
I'll be back in a
Awesome.
bit if you guys are still on.
Yeah, cool.
Okay.
Good to see you. Good to see you, Internal. I always love talking to the students, dude.
course.
Yeah, man. If you guys ever just want to like chime in, say hi, like,
Yes.
please do. Let me know how y'all doing.
That's the
Doesn't
only amount of time I got.
That's good, dude. That's good. That's what counts. Okay, Teacup, what's up? You
Yes,
here?
sir.
Where's Sir Teacup? Teacup. I'm sorry, Teacup. I made you wait like 3 hours last time. We had like a ton of questions. Monday is like a super busy stream because I think everyone wants to get their credit in for the week, and then that hits us on the front page, and then I get more people coming in, and so like it just becomes like a massive queue. Yes, Jamarcus, I know you got to leave soon, so yeah, I'll do yours next. Because yeah, I didn't get to yours last time either, so we'll do yours this time. Yes. When you try to get a PhD, do you have to write a paper? Is there a test too? Yeah, you definitely have to write a paper. I had to write a 100, 200 page paper. You have to discover something is what happens. Where is it? It was like, here's my thesis. Take a test. You have to take what's called a qualifying exam your second year of grad school. Well, in between your first and second year of grad school. It's a pretty tough exam. It's kind of like a final exam for all the physics classes you took your first year. And in my grade, 30% of the people fail that. Like, they purposely fail 30% of the people. It sucks. I luckily passed by the skin of my teeth. Yeah. Going to copy, thanks. Yeah, right. Okay, here, let's do this. Sketch the slope field of y dot is equal to t squared minus y. Okay, this is cool. He's like this is a little bit of vector calculus almost. Okay, so teacup y prime, which they put as a dot, which also usually is written as this. This is also regarded as like dy d something, where whatever that something is usually the other variable here. Usually we have like y is equal to something as a function of x. This is y is something as a function of t. So when we derive, we're always looking at how much is this changing compared to how much is this changing. So this is going to be dy dt. And they're saying this is equal to t squared minus y. So this is kind of weird because it's saying that the slope of something, like, and let's remember, right? If you have like a curve, like something that looks like this, right? The slope of something, they're saying, is also proportional to like where you are in x, which in this case is t, and where you are in y. It depends on both things. It's kind of weird, is what it is. Isn't it hard to discover new things though, or to take a lot of time? Yeah. So you don't have to discover like the most amazing new thing. You just have to discover something new. I think I've described this before on my previous streams that like knowledge is like a big bubble, and every time there are like scientific advancements, it's because you have like a bunch of like pimples of knowledge that are like growing. And what that does is that just expands the circle of knowledge. So, yeah, in my PhD, I didn't discover anything like revolutionary. Like I didn't like reinvent the wheel, but I discovered something that moved the field a little bit more forward, and that moves the overall like sphere of knowledge forward. That's how thesis stuff works. Yeah. Okay. Okay, so this is saying the slope is proportional to this. This is actually kind of interesting. I wonder if, we'll see. Wolfram Alpha will be able to do this in a bit. But okay, let's write these as things. Let me write this as like, let me say this is like y, and then let's say this is equal to t. Thanks for picking a low level question too, Teacup too. Like, yeah, don't pick like number 56. That's like a hard one to like show you guys. So here's what a slope field looks like. Slope fields look like this. See all this like crazy shit, right? Yeah, it kind of looks like, I don't know, maybe you guys have seen these before. This is an example of a slope field. So kind of like what like a wind curve is or something. Isu says, hi, I would like to know if you could do an integral using the residue theorem. I can. I know the residue theorem. Here, Isu, join our Discord. And then there's a channel in there called Help Screenshots. Send me a screenshot of an example question that you need with the residue theorem, and I'll try to do it if I have time. If not, I'll get to it on the next stream. So, yeah, for those, there's a queue of questions. But for those that find me on Twitch, Discord's the best way. I'm going to make a system, actually. I'm going to make a link that people can submit things through like a Google form, so you don't have to join the Discord. But I think it's a lot better if you do, because you get to see like what we're doing all the time. Anyways, these are slope fields. So you could kind of think of these as, I don't know, like a contour graph, or maybe like, how wind looks, like where like a particle would get shot off. So like, for instance, if a particle was, can I like copy this image in? I wonder if I can. I wonder if it's going to move. Oh, it doesn't. Okay, but whatever. Okay. So for instance, if you were a particle, like, I don't know, like a feather or something, and you're going around here, right? You would probably follow this path if you got caught in like this slipstream. But if you like gotten caught in this slipstream, you'd probably follow this path. Or, if you're a little bit to the left, you would follow this path. So slope fields kind of describe where things get pushed into going. They're very useful in physics. Fields, these are called fields, is what they are. I fell asleep in the middle of the stream on Monday. I'm sorry, Diva. It's okay. Yeah, I know. It was a long one. It was 3 hours. It's okay. Okay, cool. All right, yeah, I'll look at that, Isu. I'll look at it if I got time. All right, so doing this one, all I like to do is similar to what we do here, right? So these slopes are all just like, for instance, this is a negative slope. This is a positive slope. This is a slope of 0. You just find points and you like graph what the slopes look there. So in this one, what I see here is that I like to always like fix a number here. So for instance, let's fix y is equal to 0. So let's say y was 0. Then I would see that the slope, right, is equal to t squared, which means the slope is getting bigger and bigger, but like by the square as we go up in t. So at t equals 0, right, you get 0 minus 0. So that's just a slope that's going to look, here, let's use red for our slopes. That's just going to look something like this at 0, right? But then let's say we go to t equals 1. Okay, now the slope is 1. A slope of 1 looks something like, you know, this. If we go to 2, now it's 4, and now it's like 8, and then, 4, 16. It gets really big. 9, yeah, whatever. It just keeps squaring, right? So what we can see here is that as we go to the right, this slope is going to keep going up. Okay. Now let's think what happens, say, for instance, let's say we fix t. Let's say we fix t at, like, 2, right, where the slope here would be equal to 4. Now let's go up in y and see what happens. So I see that as y goes up, right, now I have, like, 4 minus 0, 4 minus 1, 4 minus 2, 4 minus 3. The slope is decreasing, okay? So in this case, we see, let's say we pick this one here, right, at 2, where the slope was 4. When it's up 1, I know it's going to be 3, and then it's going to be 2, and then it's going to be 1, and then it's going to be 0, and then it's going to be something like this, all right? So that's kind of how, like, what we know what it is, right? It looks something like this, okay? And I could draw the rest of these. For negative t values, if we hold y equal to 0, it does the same stuff. It's going to still also be positive, right? Oh, because this is t squared. It doesn't matter if it's negative. So it's going to be like this. And then the same thing. It's gonna drop as we go up. It's going to do like this. So this is kind of cool. So I can already kind of tell that the slope field is looking something like this, for instance, right? It looks like we're kind of like moving this way. We should also see what happens as t gets negative, okay? So, sorry, as y gets negative. So as we go down into what's called like the negative y values, minus and minus is positive. So this slope is going to go up. So that means, for instance, if I have a slope here, as I go down, now it's going to get even bigger. And same thing here. Bigger, 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 bigger. Okay, cool. So yeah. So now I definitely see a pattern here. And I could fill in all the rest of the ones here. But in general, what it looks like is that it's doing something like this. Okay? So if I wanted to graph this, I think Wolfram will do it. Dy dx is equal to, what was it? X squared minus y. See if it'll do it. Want to graph me a slope field? There we go. Wow.
That's dope.
Cool. Look at this. Look at this, guys. Looks kind of similar, right? Kind of what I was thinking. Except I guess because I didn't really do this quadrant, but you can kind of see it looks kind of like the same thing, right? So, and then here, this is our axes. This is x is equal to 0. This is y is equal to 0. So yeah, I kind of see the same thing, right? Look at this. Yeah. It's interesting that it really starts spiking up. It starts spiking up again. Yeah. So there's kind of like this. So anyways, that's how you draw a slope field. A lot of graphing and plug and chug, but nice. Good job, Teacup. All right, let's see. Okay, who's next up? Jamarcus, you said you got to go pretty soon, right, Jamarcus? And then I'm gonna try to do everyone who hasn't gotten credit this week yet. That'll be my priority. I do have to leave in an hour and 10 minutes. I have to go because I have to go teach. A lot of people have exams now because it's the middle of the semester. Deba, bad word removed. What was the bad word removed? Deba, what was it? Here, you can say bad words, Deba. I trust you. Where is that role I have? What is it? Can't say bad words. There you go, Deba. You can say what you want. No, Deba, you can. It's okay. I trust you. Okay. All right. Let's see. Wait. Oh, this was energy. No. You had another one, Jamarcus. What was it? Where did you post it? Or you didn't put it in the screenshot? Oh, you put it in the text. What was your question, Jamarcus, on the text? What was it? I gotta find it. Oh, did you put it in office hours? Oh, there we go. Okay. Got you. Okay, got you. It's this one. Yeah, this is why I always put screenshots and help screenshots, because otherwise I have to go hunting for your question. And it's hard. Math. Okay. So Jamarcus says, can we go over eigenstates and eigenvalues corresponding to operators in a stream today, like how to find them? Sure. Okay. Dr. Gold, do you need to make a discovery to get a PhD for every science field or only physics? Every science field. You have to discover something unique. Yeah. It's easier in some fields than others, right? So, for instance, if I need to make a discovery in, like, gender studies, you could just study whatever the fuck is going on right now. Because, like, I have no clue what's going on. So, that's pretty easy. That's what we call, like, low-hanging fruit. That's pretty easy to write a PhD about, because there's a ton. No one understands what's going on, so you can easily write about something that would be new. I don't understand how people do PhDs in math. Maybe because I'm not at that level of high-level math, but to me, like, finding new discoveries in math seems, like, impossible. Maybe I should get, like, a math guy here, a math PhD, to show me, like, what a new discovery in math is. What did I discover? Go read my thesis. It's there. I'll explain it on another time. Okay. Okay, Jamarcus says eigenstates, eigenvalues. Okay, cool. Well, let's go to Google. Eigenstates, eigenvalues, operators, stuff like this. Yeah, okay. Of the Hermitian, dude. Yeah, dude, these people gotta calm down, dude. All these things. Yeah, okay. Yeah, here we go. I like hyperphysics. Okay, here. Let's just talk about it. Okay. So remember when I talked about quantum mechanics dealing with wave functions, right? Wave functions are this. They did describe, like, where a particle is, and a lot of times we do, like, the particles in, like, a well or something. You can find, the probability of something. A wave function tells you, like, approximately where you think a particle will be. It's actually a pretty cool thing. This goes down to, like, the Heisenberg uncertainty principle, which says that we can't know exactly where something is and exactly where it's going at the same time. There's always going to be some error between the two. Like, the more I know exactly where something is, the less I know where it's going. Now, this is for particles that are on, like, the subatomic scale, like super tiny things moving at the speed of light. So yes, in real life, I know this pack of gum is here and I know it's standing still, so I can say, okay, I'm pretty sure now this is where it is. But if you look down at the atomic level, trying to figure out, like, where the individual atoms on this pack of gum are and where they're going, you can't. There's uncertainty all the time. That's called the Heisenberg uncertainty principle. But if you wanted to figure out where something is, you integrate the wave function over the places that you're trying to look for it. And this is probability. This is kind of the same thing when we do like z-tables in statistics. If you guys have ever seen these before, z-tables, like, show you, for instance, like, what's the probability that a number, right, is less than this or a number is greater than this. It's kind of the same stuff. We use integrals to do this as well in quantum mechanics. It's just things aren't like a bell curve. Okay, so yes, eigenvalues and eigenfunctions work the same way they do in linear algebra for math, in which you have an operator. This is called H. Operator is like something that, like, does stuff on things. Think of it as like a microwave, or, I don't know, a sledgehammer. It does stuff to a wave function, and that always gets you an eigenvalue times the same wave function. And this wave function here is called an eigenstate, okay? It's kind of a cool property because the operator here is usually what's a matrix or a vector, and the eigenvalue is a single thing. It's a single value. It can also be a vector, I guess, per se, but it's usually less dimensions than the operator. So we use it a lot for energy. Yeah, usually it's like a wave function being operated on something gets me an energy times the same thing. Yeah. Energy eigenvalues, that comes from this. So this was kind of cool. Remember I was talking about if you had, like, a particle stuck in a well, it would bounce between the two edges with certain energies. This has to do with what we call eigenstates. Eigen means one in German, so it means like singular. So there are only certain states that this particle can be in. And that's where we have like n equals 2, n equals 1, n equals 3, 4, 5. And this is all the same stuff. Let's remember that is seen in chemistry when we do like the electrons are around the hydrogen atom at certain places. So when you're figuring energy eigenvalues, it's the same kind of technique. You use this equation. E are the eigenstates, and then the operator I think is usually, what do they use the operator for here?
Bro, I'm back.
What's up, dude? This is it.
I'm
This
just
is
having a
it.
question.
This is
No.
it. Time evolution, time independent. Yeah. As an example question of like, I mean, let's just look for an example question. Find the eigenvalue of state quantum mechanics. Let's just look at one. I'm not going to do one because it would take me too much time to relearn quantum, and I don't really remember quantum. Yeah, Jesus, this stuff gets like stuff gets so complicated, man. If you want to learn how to figure out eigenvalues and they call it eigenvectors, which in physics we call eigenfunctions. So that's the only difference. You want to be able to do it this way. You should be able to figure out an eigenvector and an eigenvalue for a simple 2x2 matrix. Is Kudu coming back? Yes, we are going to do it. Don't worry. Yeah, I will do that. Yeah, we're going to do Kudu back again. So here, find the eigenvalue. Linear algebra. This is what I would start with, Jamarcus. I would start with this. Finding, for instance, the eigenvalue and eigenvector for this. So, for instance, they give you a matrix. This is what an operator would be in quantum mechanics. And they give you the eigenvalue, okay? And then they're asking you to find the eigenvector. And in quantum mechanics, the eigenvector is the wave function, which describes where a quantum particle is. So yeah. That's where it all comes from, Jamarcus. But yeah, if you want like some good practice, just look up on YouTube, dude. Like, yeah, like I don't know, like this is great. Whatever. Do they do something? I really got to get like, yeah, was it whatever premium thing? Oh, this guy looks like a real
this
character.
Approximation method actually indicates another interesting way of finding an eigenvector.
This guy's
What
kooky
equals
as anything.
Times vector equals minus x.
Oh, I kind of like it though. But yeah, okay, cool. So Jamarcus, check that out. That guy looks pretty cool. I like the best way to learn is to do. So do some examples and you figure it out. Cool, nice, good job.
That's dope. That's dope.
I think it's my turn, right?
I'm doing people who haven't gotten credit yet. That's what I'm gonna do first.
Okay.
If I have time, I'll get to you. But sorry, today is kind of a short day. I gotta do stuff. Okay, cool, awesome, great. Oh wait, did I already give you weekly credit, Jamarcus? How many coins do you have? Whatever, I'll check. Jamarcus, did I already give you credit this week? Oh yeah, I did. Okay, good.
That's dope.
Thank you for being honest. Take coins at Jamarcus. 2. He's like, but I'll take the 2,000. How do I take coins? Oh, subtract. I'm an honest man. Okay, whatever. I'll figure it out. You just remind me how to take it later. Okay. Who else hasn't asked questions? Well, let me see. Who else needs help and hasn't asked questions? Taco Cat, I know you have. Obama has not. Yeah, Obama, you haven't. Okay, Obama, you here? What's up? Obama, I'm gonna tag you. This is good. I like this. These are good questions. This is let's see if Obama shows up. Obama doesn't show up. I think Saint, you're probably next. Saint, I know you haven't done one yet, have you? Yeah, Saint hasn't done one. Okay. Saint. There we go, Saint. You guys, yeah, good to see you, Jamarcus, dude. All good. Deba, did I give you credit? Deba, I did not. Okay, here, Deba, let me do yours. Okay, I'll do yours first. Okay, see ya. What's up, Diba? You want to come on stage? You can speak, or you can just speak in the chat. What do you want to do? Diba is typing. I will in chat. Okay, cool. Obama, I'm gonna do yours next, so stick around. Stick around. Okay. Okay. Complete each problem by evaluating an expression for the variable that is indicated. Okay. I feel like this is not too hard. Okay. Do you know how to do? Here, I'm gonna make some harder ones for you, because like this is easy shit. You were at school? Okay. Let's say, okay, we'll do a basic one first. Okay, do you know how to do this one, for instance, Diba? Let's see you doing this one. All this is saying you to do is to plug in wherever there is D, they want you to plug 3. Yeah, don't be sorry, dude. It's okay. Like, yeah, it's okay if you don't get things. I just want to make sure you get it. So... yeah, no, it's okay. It's okay. So when they say evaluate the expression for the variable indicated, all they want you to do is any place you have this thing, you need to replace it with this number, okay? So when we do this one, I always like to put parentheses around things too, and you'll see why, because some weird stuff happens. This one would end up being 3 squared minus 2 times 3 plus 3, okay? Do we see that? Stop. Which 3 squared, we should know is 9. 2 times 3 is 6. Plus 3. And now, this is just going to give you 9 minus 6, which is 3. And then plus 3 is going to be equal to 6. Does that make sense, Diva? You see how you just plug the numbers in. It's not they try to make it look tricky, but it shouldn't be that tricky. Kinda. Okay. Well, let's try another one. Let's say evaluate. How do they write this? Okay. They said let's say 4x plus 3 when x is equal to 2. How would you do this one, Diba? You tell me if you know how to do it. Is it like 4 times 2? Exactly. Yes. So again, all you do, replace this with whatever this is, okay? So this is going to become 4 times 2 plus 3, because it used to be 4 times x. Now it's 4 times 2. Is this algebra 1? It's probably algebra 1. Yeah. So this becomes 8 plus 3, right? Do this one first. This is the whole PEMDAS thing, right? Do the multiplication first, and then you add it. And you see how that gets you 11, Diba? Yes? Okay, cool. Let's make it harder. All right. Harder. Let's say it's, let's say 3. X, I'm going to make this kind of weird. X to the 3 minus 2x for x is equal to negative 2. Okay? This is going to be definitely trickier. It ruined my day every day. Uh-oh. Okay, yeah. All right, what do we think the first step is? What's the first step here, Diba? I know it looks like a lot of stuff is happening all at once, but it's not that bad. Is it 3 times 3? Close. Okay. So what I need to do first is I need to substitute anywhere I have an x here, Diba. Anywhere an x, I need to replace it with what this thing is. Okay, yeah. It's not 3 to the third. And 3 to the third means 3 times 3 times 3, like 3 times, right? So 3 to the third, Diba, that's 3 times 3 times 3. This tells you how many times you multiply something, right? So if I have like 2 to the 6th, this is 2 times 2 times 2 times 2 times 2 times 2. Yes, 6 times. Good? Okay, good. Awesome. Yeah, no, totally cool. We're just trying to make sure, we got to make sure you understand like the, you know, the fundamental stuff, then we can get to the harder stuff. So, but the first thing we do is we're going to replace all these x's with a -2, okay? So, that is going to become -2 to the 3, and then this is going to become -2, okay? Do we see that so far? Do you see how I just replaced this everywhere we had an x? Yes? Okay, awesome. Okay. Now, let's remember PEMDAS, right? First thing I got to do, right? Parentheses. Nothing's really happening in the parentheses. They're just numbers, so we don't really have to do that. What's the next thing in PEMDAS? What's the next thing? What does this E stand for? Please excuse my dear Aunt Sally, or what is it like? I don't. There's a lot of like funny acronyms to this one. You don't know? Okay, this is exponents. And then I really like to say like this is multiply and divide, but these are like together, and then this is add, subtract. And these are also together. Okay. So, looking here, Deba, do we see anything with exponents in it? It's okay, Saint. Yeah, just chill. Just chill in the chat. We'll be getting to yours pretty soon here. It's okay. So exponents, Deba, right? Do you see how we have an exponent right here? Right, something to an exponent? Yes? Okay. So let's evaluate that first. Let's try to figure out what this thing is, right? So this is -2 to the 3rd. Do you know what that is? It's okay if you don't. I'll show you how to figure it out, but this is important. Need more water. -2 times -2 times -2. Very good. Yes, exactly. -2 times -2 times -2. Right, very good. Nice. Right, 3 times. So this ends up being -2 times -2 is 4. And then 4 times -2 is -8. Okay? This is also an important property of when we have odd exponents. You'll learn this later in math. Negative numbers to odd exponents stay negative. If this was an even exponent, Deba, let's say it was -2 to the 4th, okay? See how this is an even exponent? This would be -2 times -2 times -2 times -2. This stuff would become +4, times -2 would be -8, and then times another -2 would be +16. So, very important thing we hear with even and odd functions is that when the power is even, right, 2, 4, 6, 8, 10, 12, the number that you raise it to will always end up being positive. If the exponent is odd, 1, 3, 5, 7, it will stay negative if the thing is negative. Okay. But good. All right, we understand that. Okay. So, this is going to be 3 times -8, okay, minus 2 times -2. All right. What's the next thing, Deba, in PEMDAS, right? We've done the parentheses. We've done the exponents. Now we got to do this stuff, right? What's the M and the D? I have a Pipple says, I wish I could go back to this math. Now it's so much more complicated. Yeah, it all builds on itself. But, I mean, I'm here to help. You know, it's not that bad. Everything seems bad while you're doing it. And then later in life, you look back and you're like, oh, that wasn't that bad. So, yeah, don't worry. If you have questions with stuff, I have a Pipple. Yeah, always just throw them in the screenshots. And I think the thing I am gonna do as I start realizing that there are a lot of questions and there's only so much of me is we're gonna have other streamers also be available to help you guys out and ask questions, and you can still get credit for them too. So we'll have the same reward system in place, but I also want to make sure that there's enough people to help you guys out. So I'm talking to some people over the week. Deba. What do I do next? Where's Deba? Mr. Bean's coming out, Deba. Don't keep him waiting. Oh, you don't know? Okay, it's all right. All right, it's okay. All right, yeah, just tell me. If you don't know, just say, I don't know. You know, that way I can try to figure out what you don't know. So we need to do multiplication next. We did parentheses. We did exponents. Now we do multiplication. You see how we have some multiplication going on here? I got some multiplication going on here. I got some multiplication going on here. 2 times -2? Yeah, I like that. Yeah, let's do that. Cool. You want to do -2 times -2. I like that too. So what you're doing here, Diva, is you're making this a plus and you're saying this is a negative. So minus is the same thing as plus negative. So now you're doing -2 times -2, which that is going to be 4. Okay? And then we still got the plus coming down here. And then what is this going to be? What's 3 times -8? Oh, Pitbull, I teach a ton of calculus. Like, it's actually probably one of my favorite subjects to teach. So, yeah, please let me help you there. So, -24. Good, exactly. All right, you're so close, Diva. Final answer, right? Now we've done the multiplication. There's no division. So now we got to do the last thing, which is the adding, right? You see how we just have adding left? What are we going to do with the adding? How do I add those last 2 things together? -22. Close. Okay. You have -24 and you're adding 4. I know adding negative numbers are fucking weird, right? Yeah. I always hate this. Yeah. Okay. Think about it this way. Here's -24, right? And you got -23, -22. Good. Yeah, you got it. -21. Just to show people. If I'm here at 24, I got to go back. 1, 2, 3, 4. Plus always moves it to the right. So, right. This is going to be -20. Nice. Yeah, very good job, Deba. Awesome.
That's dope.
Yeah, is that how you remember it, Obama? Is that how you remember it? That's kind of funny.
Hey, Dr. Go.
Yes, what's up, dude?
I want to comment on someone's question.
What's up? What's someone questioning?
About triangles, literal triangles. I could help them with that.
That's cool. Yeah, I should have like some student teachers. That's another thing I should do. Okay, Obama, you're next. Let's roll. What's up? Is this your pre-calc class or something? What are you taking again? You taking pre-calc, right, dog? You want to come on stage? You want to say hi? Come say hi. Bum, 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 bum.
Hello.
What's up?
That's dope.
Yeah, it's pre-calc.
Pre-calc. All right, cool. Copy again. Saint is your friend? Saint goes to school with you as well?
No, we're in the same middle school though, but he moved.
Oh, okay. That's cool.
We still talk though.
That's dope. Yeah, you guys have still the internet to like talk to each other. Back when I had friends in elementary school and I had to move, it was like, can you mail me a letter? What the fuck?
Nah.
Y'all can just like hop on Xbox Live or something and just like play with each other. That's kind of cool.
Yeah.
Oh, Saint says he low-key a bum though. He's low-key a bum.
He's
dude.
tripping. He's tripping.
Tripping, dude. Why is this image taking so long? You sent me another high-resolution image. Y'all sending me like, there we go. Look at this, dude. I can get down to like the nitty-gritty of things. Okay, cool.
Is it that bad? Wait, is it actually bad?
No, it's not bad. It's like too good. You know, that's what I say.
Oh.
Okay.
Oh yeah, that's just my phone camera.
Oh, that's okay. It's okay, dude. Okay, cool. Let me help you with a hard one first. Here, I'll help you do 6. You need 6, right? You need help with 5 or 6?
Annie. I had
Okay.
a quiz on this and I lost. This is the only thing I lost points on.
Okay, it's okay. All right. What I always like to do first is draw what like the center line is going to be, right? Does that make sense? Like all
The
these things.
midline?
Yeah, all these things do this around like some midline or whatever you call it, right?
No. So look, I know the amplitude, the midline, I know all that, but when it comes to actually doing the line, that's where I fuck up. Like I
Okay.
know the midline's -3.
Well, okay, let me do 6. Let's do 6. Let's just do 6 because 6 is harder. I want to do 6. Okay.
Yeah.
Diva says, can I buy 1,000 V-Bucks more than one time? You can only buy the 1,000 one once, but tier 2 I think is like 2,800 V-Bucks or something. You just got to get more bond coins. Yeah, the more coins you get, the more the rewards are. And then I don't know. Some of the people in this Discord, I bought like the 10,000 V-Bucks or something for you guys. Like I bought some big fucking V-Buck packs. Okay, so this one, right? The midline being 1, Obama. I'm just gonna like draw like a dashed line just to start with is what I'm going to do. I'm going to do this. I'm going to just draw like a dashed line, okay? Right here at y equals 1, all right? This will help me out, okay?
Yeah.
All right. The next thing I want to do, I want to look at what the amplitude is, right? So, like, what's the biggest and what's the tallest going to be, right? So, what's the amplitude here?
2.
Good, 2, right? So, that means I know it's going to go 2 up, and I know it's going to go 2 down eventually, right?
Yep.
So, that's what I draw next. So, up from 1, going up 2, right? That's going to get me up to 3. And then going down 2 from 1, that's going to get me to -1, okay?
It starts at 3 too. It also starts at 3, right? Because it's a cosine.
So, yeah, we'll get into that. Yeah, because your teacher could put some more tricky shit, right? Where, like, they move this or something, right? Have you seen that before?
I mean, I feel like this is pretty easy. Like, I understand everything, but I don't know. Like, the graph for it, I don't know. It's just
All right, well, here.
confusing.
I'm showing you how to do the graph part. So, set this up. This is just, like, setting yourself up for success, right? Like, let's just set this up,
Mhm.
okay? And then what I do is I usually make a table is what I do, right? And I look at, let me think how I do this. I look at when is this equal to 0 and when is this equal to 2 pi. That's what I do, okay? I look at the inside. I say, okay, 2x is equal to 0 when, and then 2x is equal to 2 pi when, okay?
Mm-hmm.
All right. So what does x need to be for everything inside here to be equal to 0? What does x have to be?
0.
0. Good. All right. And then what does x need to be in order for this to be 2 pi?
Pi.
Good. Cool. All right. These are your endpoints is what I say, okay? So in, like, for instance, a sine or a cosine graph, right? You always have the start and the end. This is the start and the end for sine, right? And then
Yeah.
this ends up being the start and the end for cosine. Okay?
Mm-hmm.
And then we're going to break it up to what I call, like, quarter points and, like, midway points, okay? So, okay, once I got the endpoints, all right, the next thing I do is I find the in-between, okay? So what's halfway in between 0 and pi?
Pi over 2.
Good. So I'm going to write this as pi over 2. Okay, that's awesome. Okay, and then I find the quarter points. What's in between 0 and pi over 2?
Pi over 4.
Good. What about here? Pi over 2 and pi. A little harder, right?
Wait, what? Yeah, I got. Wait, what? Pi over. What's between pi and pi over 2?
Pi over 2 and pi.
Zero.
Like, no.
Isn't it?
What's the halfway? So if you ever want to know where the halfway point is, right? Just add these two together and divide by 2. You're finding the average, okay? It's like pi over 2 plus pi over 2. That tells you where the midpoint is between these two things, okay? Does that make sense? Yeah.
Nah. No,
Okay.
not really. I don't.
Okay, let's say I needed to find the midpoint between 3 and 6.
Mm-hmm.
What's that going to be?
Is it 3.5?
No, it's not 3.5.
No. 4.5?
4.5.
Nice.
It is 4.5, okay? Watch how I did that. I did 3 plus 6 divided by 2. See, that's 9 over 2, which is equal to 4.5.
Mm-hmm.
That's how you always find, like, the middle between two things. Okay?
Okay.
Okay, cool. So in this case, pi over 2 and pi is this, right? How do I add pi over 2 to pi? Common denominators, maybe, right?
Yeah, but put the 1 on the bottom. So pi over 1.
Well, that's a 2 and that's a 1. Not the same, right? How do I
Wait, so
make them the same? How do I make this to have the same denominators?
multiply by
as-
2?
It's 2 over 2, right?
Mm-hmm.
Okay. So I have pi plus 2 pi, which is how many pi's?
3 pi.
3 pi over 2 divided by 2. Do you know how to do this? Do you know how to do fractions over fractions?
Do you cancel out the 2?
Nah, not quite. No. Dividing fractions, easy as pi. Flip the second and multiply. Or I think you guys call it like keep, change, flip or something. Or keep, change, flip.
Yeah, I don't know.
So this is 3 pi over 2. Flip the second. So instead of 2, you have 1 over 2. And then you multiply them together. Okay. So this gets you 3 pi over 4.
Okay.
right? Dividing by 2 is the same as multiplying by a half, right? Like if I have $10 and I split it in 2, it's the same thing as just multiplying it by a half. So if I have 3 pi over 2 and I need to split it, I just multiply it by a half. And then that gets you 3 pi over 4. Yeah? Okay.
Yeah.
Cool. All right, good. If anything doesn't make sense, Obama, you know, tell me, like, bro, like what?
I know.
Like, hold the fuck up, dude. Okay. All right, cool. All right. So now what I do is so these are the x values. These are like my cool x values. So I know I'm gonna have something at 0, pi over 4, pi over whatever this, 3 pi over 4, and pi. Now I need to just figure out like where this shit goes. Okay. And so here's the important thing. So now you have to kind of remember your unit circle a little bit. I know.
Yeah, I forgot about all that.
Oh, okay. Well, this is where it's useful.
Well, she gives us it.
Okay, she gives it to you. Fuck yeah, great. Okay, so if I plug in 0 right into here, what do I get?
Hold up, my phone's. Hold. Give me 1 second.
You're good. You're good.
Hold up, let me read it on my computer real quick.
Okay.
My phone free.
Yeah, because his phone's dying. You're good, dude. Deba says, I wanted to sell V-Bucks to my friend, but I won't now. I don't know when is max. Is it possible to transfer bond coins to another account? No. I stopped. I used to allow people to transfer bond coins to people, but then everyone started creating alts. So they would create new accounts, or they would create multiple accounts and do all the basic things and then pool them all into one account, and like you can't do that. I get it. You kids are resourceful. You try to find hacks, but like you can't do that. I have ways of stopping things. Okay. Obama. So if I plug 0 in here for x, right? Which means the whole thing, right, ends up equaling 0. What's cosine of 0?
Well, isn't it just 0?
No.
Cosine of 0?
Sine of 0 is 0. Cosine of 0 is 1.
Oh.
So this whole thing is going to become 1. Okay? And then and then what do you have? What do you have for your final answers? If this is 1, right? And then you have -2 times 1 plus 1. What's that going to be?
-2 times 1 plus 1?
Mm-hmm.
-1?
Good. Yeah. Do you see how that's going to be this point right down here? Okay? Okay. So now, this is cool. I'm just going to show you the hack, all right? So I know this is like my starting point, right? And then my ending point has to be the same thing, right? When we do this, when we say when is it 0 and when is it 2 pi, we're finding the starting and the end. And the starting and the end are the same, okay? So I know this is -1, which means I also know that this one is -1, okay? So now you can just go right ahead and also put this over here, okay?
Yeah.
Kind of cool? All right. Then I know...
Hold on, let me write it down, because I still haven't actually, like...
I'll take a screenshot. I'll take a screenshot and send it to you. It's okay. Don't worry.
Okay. Yeah,
you'll get a screenshot. Okay. Now, the halfway point, right, between the start and the beginning, right, is always going to be... Well, actually, let's not do that, because that gets kind of, like, messy. Here, let's just figure out the halfway point. Okay. So if I plug in pi over 2 into this, what do I get?
Pi over 2 pi over 2?
What's 2 pi over 2?
I think 2? No, pi.
It's just pi. Okay. What's
Yeah,
cosine of
it's
pi? What's cosine of pi?
What?
Okay, let's remember this.
No.
Okay, this is pi, right? This is 0, right? Which is also 2 pi.
Uh-huh.
This is pi over 2, and this is 3 pi over 2, okay? All right? And then remember, cosine is the x-coordinate, okay? So here at 0, the x-coordinate is 1. Here, the x-coordinate is 0, right? And then here, the x-coordinate is what?
Half for 1?
No. Here,
Huh?
Ah!
Sorry.
It's okay. Okay, look. Let's say I'm moving my angle around like this, right? You see this? Moving this shit around, right?
Back.
Like that, right? Cosine measures what the x component of this thing is. The x component refers to this, like this amount, the blue amount, okay? Okay?
Mhm.
So when this thing comes all the way down to pi, do you see how the x amount is the full thing? It's the full radius. And then what is the name for this thing? What do we call this thing? The what circle?
What the unit? The unit? What?
Yeah, yeah. Do you know what unit means? Like besides like absolute unit? What does unit mean?
Like a single thing? Like
Single. Yeah, it means one. It means one. It means one. Okay. The thing about the unit circle is that the radius, Obama, is always 1. Okay? So this length here,
Mhm.
this red length here is always 1. Okay? So eventually,
Okay.
when this thing gets like down to here, right? Its length is 1, and almost all of that radius is in the x direction, which is cosine. Cosine refers to the x direction. Nice. Good night, Deba. Okay, yeah. So when we're here, right? This is going to be equal to -1 because it's on the negative side, right, of the x-axis.
Yeah.
Okay. Right. So that's why cosine of pi is -1. Yeah, getting kind of
All right.
closer. Nah, no. It's the unit
Getting
circle.
No, it's because like my teacher taught me like a whole different way, and it's just confusing to me.
Does your teacher's way make sense to you?
Honestly, it would if she slowed down,
Oh.
but
Totally
she
like,
just goes too fast.
just got chill in the Adderall, dude. Here, I'll show you, dude. It's where's a fucking picture of this? I hope this is not one of these retarded, like, they pretend it's a PNG, but it's not a PNG. Oh god, dude, what? Dear Lord Heavens. Dude, I can't read that. No, also PNG. Can I just get something that's blank, please? Thank you. There we go. Okay. You've seen this before, right? It's like messy clusterfuck. No one likes this thing, right? Yeah, okay. So, here, I'm just going to show you. Like, okay, so this, right? This is going around the circle, right? And it has different angles. So, for instance, right? This is it at 30 degrees. This is it at 45 degrees. This is it at 60 degrees. Okay?
Yeah.
That makes sense so far? All right?
Yeah.
Whenever we're at like a certain angle, the amount of this angle that is in the x direction, this is cosine. And the amount of this that is in the y direction, this is sine. Okay?
Okay.
At 45 degrees, right? Do you see how the amount here is going to equal the amount here? Because it's like, it's, you know, it's,
Yeah.
okay. That's why cosine is square root of 2/2 and sine is also square root of 2/2.
Mm-hmm.
That's why they're the same number. The why they're square root of 2/2 has to do with a 45 45 90 triangle, which I haven't, like, I'm not going to go into right now, but okay. But then look what happens, right, if we go over to here, right, to 135. That's also, right, a 45 degree angle, okay?
Yeah.
So this side should be the same as this side, right?
Yeah.
Remember, this is the cosine and this is the sine?
Yeah.
Look, they're the same. The only difference here is, look, the cosine is negative. The reason why it's negative, right, is because it's on the negative x side. The sine is positive because it's on the positive y side. Okay? All right. Now look what happens as I bring this thing very close down to pi. Okay? Do you see how the amount in the x direction is almost the same amount as the hypotenuse? Right?
Yeah.
The amount in the y direction basically goes down to 0. Right? This is why sine of pi, right, is 0. Because you have basically no y direction once you get this close to the 180 degrees, to the pi. But the x direction starts equaling the same amount as the hypotenuse. Which, let's remember, the hypotenuse is always 1 because the radius of this circle, no matter where you're at, is always equal to 1. It's a circle, okay? So this is why cosine is negative, and it's negative because it's on the left side. right? So that's why the cosine is -1. Does that make a little bit more sense?
Kind of, yeah.
Okay, cool. All right, whatever.
I mean, I'm the sine and cosine part. I understood that. Like the sine is y and cosine is x, but
Good. So, I mean, just look at it. Look at it.
But-
Look. Do you see how this is y, this is x, right?
yeah,
And then let's bring it down. You see how this is y, this is x?
yeah,
Let's bring it down even more. This is y, this is x. What's happening to y?
just getting smaller.
It's
Like
getting smaller, yeah. Eventually, it's going to be 0. What's happening to x?
it's getting negative.
It's
Is it
getting
staying negative.
well. It's getting bigger, but sorry, you're right. It is getting more. It's getting more negative, right? You see that?
Mm-hmm.
What's the biggest negative it can become? Like, what's the most negative in the x direction it can become?
-1.
Good. And that happens when you're here, right? That's when
Yeah.
the x is the most negative. Because then when I start going this way, right? Now my x is less negative. Until eventually we get to here, right? Now my x is just 0. Right? Do we see that?
Yeah.
Yeah. See how, like, for instance, here, the x is very small. Now the y is very big. Or very negative. And that's why y sine ends up being -1 once we get down to 270 degrees. Cool? Okay.
Yeah.
So back to what we're doing here. Okay. Plug in this point, pi over 2. You found out that was cosine of pi. Cosine of pi is -1, right? So this whole thing here is -1. What does that mean our expression is? What's that going to be?
Yeah, I got no clue.
Don't give up yet.
I'm actually so lost.
No.
You just lost me right there.
Well, I know, because we went all the way back into teaching about this. Okay, let's go back to, like, we have points here, right? These are x points, right? We already figured out when x is equal to 0, y is equal to -1, because we just plugged this back into here. Do you remember how we got -2? We got -2 cosine of 2 times 0 plus 1 when we
Yeah.
plugged in x equals 0. Let's remember, right? This was cosine of 0. Cosine of 0 is here. That's +1, right? Remember, cosine is the x direction.
Mm-hmm.
Okay, so if this whole thing is +1, what's the entire thing going to be?
0.
No. It's -2.
Negative
Times
2 plus
1.
1 is
No, -2
negative.
times
times
+1,
times 1.
which is -2 plus 1,
Just -1.
-1. Good, that's how we got this. Wow, thanks for the follow, Mr. Stone Star. Wow, we hit 701 followers, dude. Fuck.
That's dope.
Dude, I think we've gained like
Yeah.
100 followers this fucking week, dude. Hell yeah, dude. That's great.
Nice.
Love it. Love it, dude. Yeah. Okay. So that's how we did this. Okay. So and then remember what I said, Obama, right? This starting point is the same as the end point. That's why at 0 I put it down here at -1, and at pi I put it down at -1. Now let's find the in between. Okay. The in between is when we have pi over 2. Okay. What happens
Yeah.
now when I start replacing pi over 2 with this thing? Ugh, I need to move this.
Get bigger.
No. Well, okay. Well, yes, but look. Okay. So now it's cosine of 2 times pi over 2. What do we say this was? What's 2 times pi over 2?
Pi.
Good. Okay, so now this is pi. What's the cosine of pi? That's what I taught you over here. I know. Bring it all back. Cosine of pi.
Cosine of pi.
Yeah, remember pi. Cosine of pi, right, is the x thing when we go all the way over here. How much is the x thing when we go all the way over here?
Was it? I think it was -1, right?
Nice.
Yes. So this, right, Obama, this whole fucking thing here is -1, right? Okay, so what is my entire expression going to be now?
3.
Good.
Wait,
-2,
times negative
-1,
yeah.
+2, plus 1.
3.
Nice.
Good. So now at pi over 2, I'm at positive 1. Right? Does that make sense?
Mhm.
Okay.
Yeah.
Cool. Or no, sorry, I'm at 3. Sorry, what the fuck am I saying, dude? I'm getting tired. There we go, sorry. Pi over 2, we're at 3, right? Because negative 2 times negative 1 is 2, plus 1 is 3, yes?
Yeah.
Okay, good. Look at this, okay? We're almost done. Okay, so I know this is 3, right? So these ones have to be the in-between points, right? So if I'm going from here to here, where's my in-between at? Where's that going to be?
Pi over 4.
Yeah, it's at pi over 4, right? And then what y value am I going to be when I go from here to here?
1.
Yes. Do you see how I'm just at the midline? Yeah.
Mhm.
So yeah, this is your graph, Obama. It's this, and then this one, right? 3 pi over 4. So this is going to be 1 and 1, right? So 3 pi over 4 is here. So it's going to be like this. And there you go. You could also
Wow.
plug this back in and do it again, but honestly, you don't need to. All you have to do is like get the starting point, which is the end point.
She
Get
just
the
said
halfway.
one cycle. She just said one cycle.
This
there.
is one cycle. You get the starting point, which is the end point. You get the halfway point, which is going to be like the opposite thing, but like verify that. And then these quarter points I talk about, these are just these are in between this the starting and the mid.
It's the thing she teaches us. She teaches like the 5-point rule or some shit.
Yeah,
And it's
this
like
is
the start point and
this is the 5-point
end
rule.
point and then like the maximum of the other thing.
Yeah, this is like the 4-point rule. Like I don't know, there's 4 of them. Oh no, there's 5. Sorry, 1,
She said
2, 3,
5.
4, 5. It's 5. Yeah, there's 5 here, right? Yeah, that's all we did. 1, 2, 3, 4, 5. Yeah,
Yeah.
make a little bit more sense.
Yeah, I mean, hopefully I can get it right in the test. But...
Okay, good. Well, practice makes
Hey,
perfect.
well,
You're welcome.
thank you.
Nice. Have you gotten credit yet for the thing? Oh, you haven't. Okay, I gotta get you credit.
No.
He's like, I want that PS5, dude.
The only reason I'm coming is I'm trying to, Saint?
I don't know Saint. I don't.
You-
I know
No,
Saint.
no,
well,
so,
Saint,
no.
Saint was goaded at
No,
our.
he's been in the
um,
server.
Oh,
But
thanks
he
PCT
left.
for the sub, dude. Fuck
He
yeah,
wants me to
Saint.
get a PS5 so I can play with him.
Oh, good. Well, then I hope he wins it. He was goaded at the Fortnite minigames. Yeah, hell yeah. Look at that. Now we're at 10 subs. Woo!
Nah, he's ass. I'm better than him.
You're better than Saint? Oh, okay. All right.
Yeah, I
Alright.
crap on him every day.
Oh, Saint said you're kind of mid, dog. Saint was pretty. He was goaded. Weren't you Prime NG? You were Prime NG in our Fortnite game, Saint, weren't you?
That's him, yeah.
I got that dog in me. He loves like. Yeah, dude. You and I forget who the other guy was that was really good.
1v1 me? Nah.
Nah,
I'd probably lose.
he says nah, dog.
I'm
Okay.
too good for you either
I'm too
way.
good. Cheers. Thanks, PCT. I appreciate you finding me on LinkedIn. Actually, I do. I guess I do have my LinkedIn link on what is it, on Discord. Yeah, I need to use that more often. I literally I had such an aversion to LinkedIn. I refused to get one, and then I started talking to enough like angel investor philanthropists, and they're like, "Yeah, bro, you need a LinkedIn." I was like, "God damn it." I so didn't want to go corporate, but all the donors want to see like something professional, so I did do that. So I appreciate you reaching out on that. You've increased my following count up. Oh man. Okay. All right. What's up, Saint? Are you in the chat? Or you want to come up and speak? You can come say hi. You want to talk some shit on Obama? Go talk on him. Obama's our character, right? Not the president. Like I wouldn't talk shit on the president. Obama's actually a pretty cool president. Yeah, he says yeah.
I don't
Why
know if he
not?
wants to talk, but
Dude, he says he wants to talk.
all right. Get in.
Dude. Get his ass up here, dude. He's up on the stage.
I don't know how to do that shit on a PC.
Yeah.
Ooh,
He's a speaker.
oh,
He's muted though.
fuck.
He's got to get his mic to.
Oh, there.
Yo, what up, Saint, dude?
What up, bro?
What up, bro? Yo, that was dude, you were dope at the what was it? The yacht game we played on Saturday. That was super. That was
yeah.
cool. Hell yeah, dude.
He sucks, bro. I beat
No,
him
dude,
every
he's
time.
fucking
No
good,
1v1.
bro. He's so good.
He
Yeah.
sucks.
Why are you hating on my name right now?
Dude, he's hating because he ain't you,
Aye,
dude.
bro.
He hating because he ain't you.
He literally-
Damn.
jealous of me.
He jealous. All right, here. Let me run through this
All right.
question. Let me run through this question. Good to see you, Obama.
Yo, he's
All
he's my number one hater. He hates on everything I do.
It's okay. It's all right.
Absolutely.
Yeah, it's like the girls that throw rocks at you because they like you in recess. Okay. Here. Oh, cool. These are polynomials. They're called polynomials. Poly means many. And then nomial means term. Yeah, term. Okay, cool. All right. Degree. This is cool. Do you know what degree is?
Yeah, but I don't know how to explain it.
Okay. What's the degree of this thing?
3, right?
3, yes. Degree is always what is the highest exponent. It's not always going to be the first thing. It's what's the highest, okay? So, for example, in this one, question 6, what's the degree of this one?
4.
Good. Yeah. A little trickier, right? Okay, cool. What's the leading coefficient then?
Is it X or just like 1? Because it's the first one.
It's just 1. So it's whatever the number would be in front of the X to the whatever with the highest degree. Whatever the number is. So in this case, because there's nothing in front of it, it's a 1. It's not a 0. Some people say it's 0. It's not.
All right.
Okay. So what about for this one? What's the leading coefficient?
8.
Ah. Tricky. Remember, leading coefficient is the number in front of the highest exponent.
In front of.
Which one was
so
the highest
7.
exponent?
Okay,
so it's
7.
7. Yes, this is the highest exponent, so
Oh,
it's
okay.
7. Yeah. I know, leading makes it feel like it should be like the first one, but no, it's the one in front of the biggest one. Okay.
Yeah, I got it.
End behavior. Okay, I guess they probably mean like to the left and to the right, like which way it goes, right?
Yeah, that's what like throws me off. That's like the only thing
Okay.
I don't know.
Okay, so here's the thing. So if the degree is even, then the end behavior is the same for left and right.
Okay.
But if it's odd, then it's a different end behavior, okay? End behavior is just saying like what happens as we go to positive infinity and what happens as we go to negative infinity for x, okay? So
Okay.
a good one here, let's say for instance I just have like f of x is equal to x squared, okay? Do you know what this graph looks like?
Yeah.
What does it look like? Like describe it as like a letter.
A T.
A T looks like a U. Looks like a U. Looks like this.
Wait, what are you talking about? Oh, I thought you were talking about like the actual thing. Okay.
No. It looks like this is what x squared looks like. It looks like a U.
Oh, okay.
Right?
Okay.
Okay.
Yeah.
Notice how what is the degree? The degree is what?
2.
2. Good. Is that degree even or odd?
Even.
Even. Okay. So that means the behavior to the left and the behavior to the right will be the same. Okay. So
Okay.
then what you do is you just look at whether this thing is positive or negative. Okay. So because this is positive, that means the behavior to the right is positive infinity, and the behavior to the left is also positive infinity. Okay.
Okay.
Because if the degree is even, it means the behavior is the same for both. And in this case, if it's positive, they're both positive. What if it was,
Okay.
for instance, negative like 3x squared? What would the end behavior be on the left and the right?
Would it be what do you mean like in terms of the
In terms of
the
like
letter would be like you?
like positive infinity or negative infinity. End behavior is just saying like what y value does this tend to go to? That's what they're asking.
Would it just be negative infinity?
Good. It's negative infinity. And more importantly, because it's even, it's negative infinity for both. Okay?
Mm.
So,
Yeah.
again, I don't know exactly how your teacher... Do you know how your teacher wants you to write this?
No, because she gave it to us today,
Oh, okay.
and she didn't really give us like a reference at all.
So I would say, like, as x approaches negative infinity, you say y equals negative infinity. And then you say as x approaches positive infinity, you're going to say something else. Yeah.
Okay.
This is... Have you seen this writing before? This is called, like, limit definition.
I have not seen that yet.
Okay, cool. Yeah. Okay, so, that's for things that are even. Things that are odd are going to be a little bit different, okay? So, let's say, for instance, we have y is equal to x cubed. Okay? X cubed, you may not know, looks like this. Okay? What is this behavior as we go to the right?
Positive infinity?
Good. And what about as it goes to the left?
Negative infinity?
Yeah, good. This is positive. This is negative infinity. Okay, so cool. So look at this. because it's odd, right? Do you see how the right behavior is opposite of the left behavior?
Yeah.
Okay. And then for odd functions, if this is positive, left is going to go down to negative, and then right is going to go up to positive infinity. Okay? If
Okay.
this switches, okay? So if we do, for instance, y is equal to negative x cubed, then it's going to look something like this. So now it flips. So now as you go to the left, this is positive infinity, and then as you go to the right, what is it going to be?
Negative? Oh no, wait, it's still positive, right?
No, it's negative. It's negative. You were right
Oh,
the
it's
first
negative?
time.
Okay.
Right, because remember, if this is odd, right, 3 is odd, then the behavior on the left and the right has to switch. They have to be opposites. So it has to be positive infinity here and negative infinity here. Yeah. So good little little thing for it. Okay. All right.
Yeah.
So let's look here. And again, you always look at the leading coefficient and the degree. This is what determines this. Okay. So let's remember. Okay, the leading one, right, is this x cubed. What does that mean about the end behavior on the left and on the right?
Can you repeat that? You cut out.
It's okay. What's the end behavior for this one?
For that one?
Yeah.
Would it be like how would I say it? Like,
Yeah.
because since the leading coefficient is 3,
Yeah.
the degree is 3.
The degree is 3, right? So I would write like what it is, right? It's odd. Okay. It's an odd. I would write whether it's an odd or even function. That's just a good thing to write. Okay. And then I think you can do it kind of like this. Just do like left behavior, right behavior.
Okay, so like in a what's the thing called? I forgot.
Parentheses and a comma or something, brackets. I don't know what you call them.
Well, damn, it's gonna bother me, but I know. I know what you mean.
Like a range, like a domain or something.
Yeah, something like that. I don't know.
Yeah. Okay. So what's the left behavior and the right behavior for this function?
Would the left one be 3
No. So
or
remember,
0?
so your behavior is either positive or negative infinity. Those are the choices you get. So it's either positive infinity
Oh, it's negative.
or negative. Good, it's negative, right? And then because it's odd, what does that mean about the right behavior?
Positive.
Right, and good, it's positive. Good. Yeah, positive infinity. Okay. What about this one?
That one.
So first of all, what type
Is
of
it
function
B?
is it? Is it odd or even?
It's odd.
What's
Does
the
it,
degree?
does it go by the degree or the
Goes by the
leading
degree.
coefficient?
Yeah. Don't worry.
Right.
This
Right.
they're trying to fuck you up here by putting this one first.
Yeah, it's throwing
This is-
me off. Yeah.
This is bad form. Usually you would put this one first, but they're doing this to mess with you. Always look at the
and
degree.
So it's gonna be 7. So it's gonna be odd.
No. You look at the degree.
Oh, the
Look at
degree. Yeah,
the degree.
Yeah. So yeah, okay, even. Yeah, okay.
even
This is throwing me
function.
off.
I know it's a tongue twister. Okay. All right. Even function. So what's the behavior on the left?
Hold on.
Let's remember for even functions, right? If you ever need to remember, just remember what like an example even function is, right? This is x squared. This is an even function, x squared.
Okay.
What's the behavior on the left?
Positive.
Yeah, it's positive infinity. Okay. And then because it's even, what does that mean about the right behavior?
Is it also gonna be positive?
Yes, good. Nice. So yeah. So again, look at the degree, odd or even. Okay. And then what you have to do is you have to look at the leading coefficient technically, because if this coefficient were negative, for example, these would flip. Okay. Then the left would
Okay.
be positive infinity, the right would be negative infinity. If this leading coefficient, let's say, was -7, then these would both be negative infinity.
Okay.
Okay? So
Yeah.
degree tells you odd or even function. Odd or even function tells you whether they're both the same, or they're different. And then you need to look whether the coefficient is positive or negative to know whether it's negative positive or positive negative or positive positive or negative negative.
Okay. Yeah, I was only struggling with it because she gave it today.
Yeah.
And like at the end of class, so we weren't able to do it because we were doing something else before, and she didn't give us a reference or anything. She just
Yeah.
kind of told us to do
Yeah,
it and see what we could do.
I think this is what they want. So here, I'm gonna do a little explanation here. Okay, so degree, right? And you're gonna do like little flow chart, right? Even, odd. Okay, and then you got to look at leading coefficient. Maybe this will help you out. And you got to look at whether this is positive or negative, okay?
Okay.
And then here's what happens, okay? So if the degree is even, right, and the leading coefficient is positive, that means the left is positive infinity, and because it's even, it means the right will also be positive infinity. If the leading coefficient is negative, then it's negative infinity, but because it's even, it's also going to be negative infinity for that, okay?
Okay.
If it's odd and the leading coefficient is positive, it's going to start at negative infinity, but it's going to end at positive infinity, okay?
Okay.
If the leading coefficient is negative, it's going to start at positive infinity, and then because it's odd, they're different. This one's going to be negative infinity.
Okay.
Here, I'll take a picture of this for you. So just kind
Yeah,
of
I was about to ask if you could.
Yeah, it's like, yo, can I get this little cheat sheet? I should make a YouTube video
Yeah.
on this one, honestly. Yeah, this is a good concept that like gets asked a bunch. But yeah, okay, cool. There's that. I think you should be able to figure this out. And then here, let me get this one for Obama, because Obama. Yeah, I'm sorry, Obama. I forgot to give you your page here.
Where he at?
Where he at, dude? He's capping, dude. He's capping.
I'm here.
He says, I'm here. Okay, cool. Does that make more sense to you, Saint? Yeah?
Yeah, I got it. No, I got it.
Hell yeah, dude. Good job.
I appreciate it.
Yeah.
You're gold.
What's up, brother?
So we're deciding classes that we take next year. And,
Yeah.
Our teacher told us about the AP thing. Like, so I can either take AP Calculus AB
Uh-huh.
or AP Stats. I don't think they offer BC. But what should I take the AP
take
or
calculus.
not?
Yeah, take AP calculus. Do it.
Oh, because I'm really bad with math. Because like, if it goes too fast paced, I
Well,
just like
I'm-
I get
I'm-
screwed over.
I'm here to give you help, bro. That's why I'm here, dog.
You're cooked.
Wait, so which one did you say? AP Calculus?
Yeah, I would do calculus. Statistics, I think, will give you more trouble, honestly, than calculus. Just because statistics has a bunch of like weird shit that you have to know.
How hard is the AP exam?
What's up?
How hard is the AP exams?
They're pretty hard. They're not the easiest.
True. Yo, AP
Uh,
Link is so hard.
I know it is. Okay.
But they
I
want you to be a writer or some shit.
Yeah, dude, I hate that stuff. This stuff's dumb. Okay, I do have to go in like 5 minutes. Is there anyone that hasn't gotten credit for this week that needs credit for this week before I go? I think. Okay. Cool. Okay. All right. Yeah. Sorry, I'm gonna end the stream because I really have to run to the student. And if I'm late, they're a first time student. I get like fired. Okay. Anyways, all right.
Bye.
Thank you everyone for coming to office hours. Sorry if I couldn't get to your question today. I tried to make sure everyone who at least got their questions for the weekly tournament credit got theirs. I will get to yours on Monday. Thank you for asking them. We're also going to open up more math streamers as eligible to get credit for. So I will talk to them. I'll give you the links for that. Yeah, Taco Cat, I appreciate you. Yeah, I know. I'm sorry, Taco Cat. I appreciate you being here. At least you got the channel points. Sometimes
We get to do my question.
I know, but I did 2 of your guys' questions earlier in the week. Yeah. Dr. Gold has to pay rent, unfortunately. Unless, like, if that sub counter goes up, then I don't got to teach other kids for money, right? Then I can teach you for free. So go tell your parents to sign your Amazon Prime, whatever, Twitch thing and link it. Yeah.
Or you could gamble.
Or you could no gambling. Anyways, okay, cool. So, our next stream is gonna be on Friday. I got a very special guest for you guys. I'll announce it later tonight. You guys ask questions, you get credit. And then that stream is gonna be an hour later at 6 p.m. Pacific, 7 p.m., 8 p.m. Central, 9 p.m. Eastern. Yes. Okay. Awesome. Okay. Thanks again to all our amazing subscribers, our boosters, our subs, all that stuff. You guys are the best. I really appreciate everything you guys do to support me helping teach kids. Good stream. Great. Yeah, who do you want to raid today? Who are we raiding? I'll give you guys the raid credit. Yeah, right? Who are we going to go raid?
Who's that first guy that looked kind of sleepy?
Who looked kind of sleepy? Which guy looked like kind
That
of
guy
sleepy?
said that he was awake all night or something. I don't remember who it was.
Here, let's go rate the science people. These people are dope. Here, let's go rate them. All right. So if you want to get some credit, go say hi to the science guys. I think they're with the paleontology guy too. Go say Dr. Gold sent you. And I will see you guys on Friday. Enjoy the rest of your Wednesday. Peace out.